Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about Leetcode question number 744. Find smallest letter greater than the target. You are given an array of characters, letters that is sorted in non-decreasing order and a character target. There are at least two different characters in letters. Okay, return the smallest character in letters that is lexicographically greater than the target. If such a character does not exist, return the first character in the letter. Okay, they want us to return the lexicographically greater than the target, but it should be the less than number which is greater than the target. Okay, let's see the example so that it will be more clear. Just see here. This is the first example. C, F, J, and the target is A. Okay. For A, the C is greater and the F is greater and also this J is greater. But the C is the first greatest value, right? It is the nearest value. That is, after A, C will be occurred. So we will return C. Okay. Now C. So whether the C is greater than C, no. Whether this F is greater than C, yes. Whether this J is greater than C, yes. But this F should be my answer. Why? Because F is the smallest number which is greater than the C. Yes, obviously. Now, see here, target is Z. X is greater than Z. No. So the four characters are not greater than Z. So what should we return? We should return the zeroth in this element. What? The X. Now clear. So what is my easiest approach for this problem? I can say just traverse. Just traverse. Go one by one. Just traverse and go one by one. And what should be a condition? My condition is if a number which is greater than the target, which is greater than the target, let's take a character, just a character which is greater than the target, then what should we do? I should take that as my answer. Why? Because it is in sorted order, right? So the first element which is greater than target, it should be my answer. So I will return the answer. Okay. So I will return the character. Okay. So this is my first approach. So what is the time complexity? I can say the time complexity is O of n. And then what is the space complexity? I can say the space complexity is O of 1 because there is no extra space, right? Now again. So this is my first approach. What is my second approach? The array is sorted, so I can use a binary search approach, right? So how can I implement a binary search approach? Okay, let's take the first example: C, F, and then J, and my target is A. Okay. Now this is my low pointer, and this is my high pointer. Now what is my mid? I can say this is my mid, right? I take another color. Yes. So this is my mid, right? Now, observe carefully whether mid is greater than A or less than A or equal to A. It is greater than A. This F is greater than A. So, what is my first condition? The mid value is greater than the target. If it is greater than target, what should I do? I can take this as my part of my answer, but still we can have a lesser value than this in the left side, right? It may be my part of my answer. So I will take this as my part of my answer. So I will take this mid value as my part of my answer, and also I will move towards what? Towards the left side. So to move towards the left side, my upper limit should be what? Mid minus 1. So now my upper limit will be shifted here, right? Right now again check. It is C. C is what? Greater than A. So again, I will shift this U here. Yes, and then take C as my answer. Now my output is C. Yes, because upper limit is fall downside is less than the lower limit. So now the condition is failed, and then I will return this C as my output. Right, right. Now again, let's take another example so that it will be more clear. See here. We can take x, y, and then z is my target. Now, look carefully. This is my lower limit, this is my upper limit. Now, this is my mid rate, this is my mid. Whether this mid pointer is less than z or greater than z or equal to z, it is less than z. It is less than z. So what is the second condition? It is the mid value is less than the target value. Then what should we do? I can say if I move towards right side, I may get a number which is equal to this target or greater than target. Maybe there's a possibility. If I move towards this left side, whether I have any possibility? No, no. Why? Because this x is of what less than the target. Then how come here there's an element which is greater than or equal to target, right? So I want to move where? I want to move towards the right side. Press one. Yes, yes. Okay. Take for example, if let me write another example. If number is sorry, the array is VB, right? And the target is A. Now tell me, this is my mid value, right? This is my mid value. Now my mid value and the target value is same. So my mid value is equal to target value, right? Now what should I do? I should move towards right so that I may get a value which is greater than the target, right? So I may or may not get, right? So I want to move where? Towards the right side. So these are the three conditions we want to put so that we can achieve the binary search approach. So what is the time complexity? I can say time of is O of log n s, and then what is space complexity? I can say it is O of 1. Fine. So you have to write this three conditions so that all binary search problems can be solved using these three conditions. Okay, one is greater than, less than, and equal to. Okay, see here and here the same operation is done. So we can combine this as less than or equal to and take out this. Understand? That's simple. It is equal to equal to. Just write equal to here, and then this both statement are same, right? This L is pointed towards the right side, so we can easily do this is less than or equal to target. Okay, let's see the coding part. Just see here. So for I in letters, if I is greater than target, then return I. If this return statement is not executed for throughout any element, then I should return the letter of 0. Fine. So I have told you, right, the immediate greater number will be came at the first occurrence, right? So that's why if it is greater than target, I just return. Okay. Let us submit it and see whether it works or not. Yes, it is working fine. Okay. Now the second approach is a binary search approach. See here, n is equal to len of letters. Now answer is equal to letters of 0. Why? The default value, if there is no answer present, is letter of 0. 0 in this character, right? And then u comma l is equal to 0 comma n minus 1. Okay. Now while l is less than or equal to u, I want to find the mid pointer first as a mid value. The mid value is l plus u divided by 2 or l plus u minus l divided by 2. Both are same. Okay. We want to do that L plus U minus U minus L divided by 2 for C++ and Java to avoid the integer overflow. Okay. Now, if letter of mid is greater than target, then we want to do what? We want to store that in my answer. It may be my answer, and then U is equal to mid minus 1. I want to shift towards left side so that I am going to check whether there's a better answer than this. Okay. And then else I want to shift the pointer low pointer towards the right side, so I shifted right, and then return ans. Let me submit it. Yes, it is submitted successfully. Thank you.